All right, so I had to, before I came upstairs to the CNC, I realized I hadn't cut this to length to fit on here. So I just went to the miter saw and chopped off a few inches. So I've got a brass 3/8 inch insert here, here, and here. My plan is to center this up on that insert, right about there and here. Try to get it square, and drill some holes through the back corners of this body and the front edge of this headstock, and screw it down, because this is all coming off anyway. And to make sure that I'm square with the CNC, make sure that it's going to cut the right thing, let me go ahead and get the CNC moved into place real quick. I was going to put a square up here so I could make sure that my pieces would center up on a square, but I have chopped off the back and that's not square, and I'm using all 48 inches of this CNC. If you had a smaller one, you could tilt this thing 45 degrees and go diagonal, but you'd have to make sure that you plan that in your Fusion 360 program. I don't think they call it Fusion 360 anymore. Now it's something else. I think it's just Fusion. So I'm using my dog holes as kind of a guide. I think that's probably pretty close, but we'll see. Let me bring this thing down. We got to hone the CNC first. Let me back this thing up so you can see everything. Hone it. Okay, we should be good. Now let me scoot this back. I want to put this at the start position. I've already loaded the program that needs to be, well, I've loaded a program to cut the holes in here. I need to go back and load the program that cuts the right size holes in the top of this, but the position should be the same. So if I go to load my file, that's unfortunate. I guess I need to put a clamp on that. And then come back here and say go to job start, or go to work origin. It says that's where it's expecting this workpiece to be at. So I can kind of check that. It's basically looking for this corner. That's actually pretty good. It's in pretty close position. So let me show you what I got to do next. All right, so here is my base in Fusion, and a lot of these sketches have nothing to do with this base. This guy had a guitar this shape that was designed, and rather than risk breaking the body, because he didn't change the body, he just changed the neck and made this transition for me. Also, by the way, I haven't mentioned, this is a through neck body. Maybe I did mention it. I think the original guitar has a bolt-on neck, but I'm doing a through neck just because I want to. You can see up here I'm putting in, I was going to go ahead and put in one of those spoke truss rods, but I have since changed my mind. I'm just going to go with the standard dual action truss rod, but I am going to go ahead and put in a couple of carbon fiber inserts. The guy that drew this doesn't build guitars, he just draws them. And so he put these carbon fiber inserts to where they come all the way back to here, but they really will scoot up and go up here closer to the nut, because one of the major things that they're to do is to stop deflection, upward deflection from right about here up to the headstock. So I'm going to put them to where they end, probably just right underneath the nut. And and then I'll bring this truss rod back out to here. I'm just going to put the standard truss rod on it. This is the drawing of the base. And I've got another drawing of just these mount points. So let me pull that up. So this is the sketch that I used for creating the mount holes in that body. And I had previously done them bigger, but then I came back and resized them for this job. So they are 0.37 and 0.3370, 3695. They should be, see, 125, 253, 75 would be the actual 3/8 inch. So let's make them 0.37, I don't know, a little bit bigger, 378. Now this hole and this hole are mirrors of each other. That's the reason when I changed one, it changed the other. But this one is independent. So let me scoot over here. Hit the D key. And 0.378. I don't know if that's going to be big enough, but I'm going to give that a shot. And then I need to extrude those holes down. So I'll just cut them through. Oh, let me first, before I do that, let me measure and see how thick this stock is, because I probably should make sure that this matches what I've actually got up on the bench. So this is set at 2 inches, but I'm at 1.9 right now. And I'm not a big difference, but it makes a difference when you're trying to make sure that you're not gouging your wood, going too fast with your feeds and speeds. So I'm going to cut this entire thing, hit the E key for extrude, and I'm going to go minus 0.1. I'm going to make sure the operation is set to cut, and then so hit my I key for the inspect, measure from there to here. There's my 1.9 inches, should be good to go. So now, and the reason this is still up here is because I extruded everything down, but it left these holes up. So I want to make sure I cut all the way through the body on these holes. So I'm just going to highlight them, extrude minus, I'll do 5 inches, whatever. It doesn't matter as long as it's longer than what was there in the first place. And you can see now that I've got a hole all the way through. They do that up here as well. Minus. Okay. So with that, if I wanted to test this, I can go over here to the manufacturer tab and let's look at my setup. I got my box point down here. It's showing me using my generic router, which is what it shows up in Fusion. They don't have a. I did bring the Onefinity model in, but yeah, it doesn't really matter. I never look at the machine. In fact, I always turn that off because I don't want to see the whole machine and everything that goes with it. So, but I've got my box point set down here at the bottom left. I've got my holes drilled all the way through. I have set. I'm going to actually delete my 2D bore and redo it. But it's showing me my stock height is 1.9 inches, so I'm good. So let me go here to my bore, and I'm going to edit the bore because the bore is actually for the last operation that I did, which is not this operation. So now, and you can see it's going to make a helical cut in there. I've told it just to kind of dig in at about 20 degrees and go around that until it gets all the way through. So let me do that for the other two. I really want that to go the other way. I want to start on this one because this is the one that's going to be easiest for me to make sure I'm positioned on. And I'm going to do a little test here first to make sure I'm dead center. Do that one first, and then this one, and then this one. And then I'll simulate that and make sure that it's going to do what I think it's going to do. No issues. That's always a good thing. Okay, that says it'll cut just fine. And but I also want to make sure, because a lot of times when I'm playing around with these designs, I'll use bits that are super long just so I don't get any kind of stock to collisions. And I didn't really check that, so let me look here and make sure that what have I got selected here. Okay, I've got the actual bit that I've got in my router selected. It's got a 1.5-inch cutting length, but it's a 2-inch bit. And I'm kind of surprised it didn't give me a stock collision because I'm cutting through almost 2 inches. But this should be fine. So now I got to do my post process. Body holes. Save to my desktop. Let me drop this down and I'll pull up my CNC interface and I'll send this to the CNC. So now I've got my Masso link up. It's kind of buggy. It works most of the times, but sometimes it just get to 80% and just stop. So I've got my NC program, my toolpath, and I'm just going to send that to my Masso. Looks like it works fine. So now all I got to do is go back up there, load that program. I want to set my Z-axis to be just touching the top of the wood so I can make sure that drill bit's going to go where I want it to go, or that end mill. So let's go back and look at that. So if I go over here to load file, you can see the body holes that I just sent over here. I'm going to load that and it shows the 3 points. I mean, not exactly a big program. It shows the 3 points, but now I'm going to go over here to program. I'm going to rewind it, but before I do anything, I want to drop this down and I want to make sure that the bit is just touching the top of the wood. So I'm going to go here to continuous mode. I've set it on 15% feed speed so I can move it. And it's not moving real fast because I don't want it to. I've got a probe, and I could stick that up here and it would set my Z for me. Let's try it. I'm going to go over here. I'm not worried about X and Y. I'm only worried about Z for right now. So let me move this up here. Put my magnet on. And I really like to be right on top of that little cutout. So I'm going to go here to probing. And I'm going to tell it to Z probe. And I always have my hand on the emergency button in case I forget something. So theoretically, that says that adding the thickness of this together with where it left off, it should tell me that when this thing is at its bottom if it's cut, it should hit right here. Now, when I'm normally doing this, I don't want to do that, but for right now, that's good. So let's test that. Let me exit my probing. And let me drop my Z down. I'm just watching this up here. And I'm going to start slowing that down. As you can tell, it's getting pretty close. I think you can tell. Let me look. Yeah, you should be able to see that. It's getting pretty close. Now, if I was Z-ing this manually, what is that, 1/10,000th of an inch? I'm going to call that close enough. So let me home this machine. And what this should do is this should come up here and come to this hole first and try to cut, but it's going to cut mostly air, and it should stop right at the very bottom and leave a little mark on that wood. And hopefully that's exactly what's going to happen. All right, so Normally the router would be running right now. And I'm just going to see if I can make sure that I can place this stock where it would have been before the hose moved in. And it's looking pretty good. That's looking pretty good. I think I'll keep that. Let's see where the next slide ends up. It's going to be right about there, which is what I'm expecting. And that's a little farther over. I can actually make a little mark over there. So, what I'm going to do is I'm going to take my clamps. Let me move this out of the way so you can see. I'm going to take my clamps and hold this piece down. I hate these clamps for this kind of work, but I hate all clamps. I've decided that there are no clamps that I like. They're just not. They all have drawbacks, but they're necessary evil. So if you're going to have clamps, you might as well have strong ones, and these are pretty strong. I'm working on a vacuum table, but I find that I get a lot of ideas from other guys, and sometimes I just wonder how these guys do the same thing over and over again, because everything I do is different all the time. I mean, this is just like a thing. That should do it. Let me do another test, then I'll reset my Z value, and then I'll do it for real. I'm leaving my dust boot off. I've got a dust boot right here. I'm leaving that off right now just so you can see everything. I just realized everything, well, while I was talking about those clamps, you weren't seeing any of that. I told you, you'll be here for all the mistakes. Alright. Another test without actually cutting into the wood. Make sure everything looks like it's lining up. Program, rewind, and it should be acting like it's running right now. Good. Looks like I scooped about a 1/4 inch. I think I'm pretty happy with that. Let me go ahead and reset my Z. Since I want my bit to end at the spoil board, I'm just going to set my probe right there. It's upside down because the reason this probe is made like this is so it's got a recess to where you can put it up against the edge of your stock, and it's going to measure from the top of the probe to the top of the stock, and then subtract that distance and figure out what Z is. Well, I don't have a top of, I don't need this, so I just need to measure this, and so I'm going to just set this right here and tell it to probe for Z. And I want to make sure I got plenty of hose. I'm over here, I'm hitting that same probe that I showed you before. Oops, stop it. This is a mistake that I often make. I forget to put a little magnet on here. If you don't put that magnet on there, it'll just hit that thing and keep on going. Next thing you know, you got a broken bit. So, probe for Z. Now it knows where Z is. And we should be good. Take it back to home. and check my camera to make sure that you can see everything. And let's run it. We'll talk about that in a second. Here for mistakes and all. I had the factor on my tool path moving that direction, and it didn't bring the, I didn't tell it to bring the bit up super high. It just had to bring up high enough to clear the stock. And because of that, it ran into my clamp. That's the reason you want to use aluminum clamps, by the way, so that when it does cut into them, it doesn't destroy your bit. I'm really surprised that the bit didn't snap. If I'd had that clamp on any tighter, it would have. But that is one of the reasons I don't like these clamps that clamp on the top of the wood, because you never know where your bit's going to go, and they're pretty tall. That's taller than the clearance of the bit, generally speaking, is over the clamps. And even when they're not tall, if you got shorter wood, then these things are taller. These things stick up. So, like I said, you got to have them, but they're not great. So let me get to my next step, which is putting my bolts in. Let me see if they actually fit in my holes. They don't. So I'll re-drill those holes. I'll just do that manually and then put the bolts in. And then we'll bolt it down and wait for my ball nose router bit to come in. And we'll do the next step. I'm just going to leave that clamped up right where it's at. Till the next time, thanks for watching.